Hi, and now we are going to go through the subtopic turning and inflection points. Okay, for the first question, they say identify the stationary points on the curve below. Okay, when they say identify the stationary points, by right we have to find the turning point, no? Okay, because stationary is also a turning point. Okay, so the first step is that what you guys have to do when you want to find the stationary point, they give us y or fx, right? You let or you find first. Okay, find dy dx or f prime x lah. Okay, after that you let them become 0, and then you find x from that. After you find x, because we want stationary point, right? So that means we have to find y. Okay, after you find y, you will get x and y, a coordinate, or more than one coordinate, or more than one point lah. So that is what it means by turning or stationary points. Okay, so we proceed first. Okay, now we have identified stationary point. We have y is equal to negative x squared plus 4x. We differentiate dy dx. We become negative 2x squared minus 1 the power plus with 4. Then here you're going to get negative 2x plus with 4. So this is your dy dx. And then remember, you have to let dy dx is equal to 0. So negative 2x plus 4 equal to 0. Then you find x from this guy. So you're going to bring 4 to the right side, become negative 4. Then negative 2 you bring to the right side, negative 4 divided by negative 2, you're going to get equal to 2. So x is equal to 2. You get x, right? So when x is equal to 2, find y. Okay, you substitute inside y negative x squared plus 4x. You substitute x is equal to 2 inside negative x squared, so become 2 squared plus with 4 multiplied by 2. So the answer is negative 4 plus with 8. Total is 4. Okay, so this is your answer for this one. Okay, now we proceed to second question, question B. Also similar, but this time they just change from fx, from the y they change to fx, the function name. So you find f prime x first. You're gonna get 3 you bring in front, so 3 multiply with 1 over 3 x to the power of 3 minus 1 plus with x squared become 2x, negative 3x become negative 3. So here you cross, you're gonna get x is equal to you're gonna get x to the power of 2 plus with 2x minus with 3. So this is your f prime x, and then you let f prime x equal to 0. So x squared plus 2x minus 3 equal to 0. And then here you see it is quad. Okay, now we proceed again. Okay, so x squared plus 2x minus 3 is in the quadratic form, right? So what you guys have to do is you have to find the value of x. We can use factorization, no? So you use factorization, then here you will get x plus 3, and then x minus 1 equal to 0. So x plus 3 equal to 0. You separate x minus 1 equal to 0. Then x is equal to negative 3. X is equal to 1. So you get 2 value of x. And then now what you have to do is substitute this value of x inside y. Easy ja. So when x is equal to negative 3, what is y? Y is 1 over 3 x to the power of 3, negative 3 cube, plus with x squared, so negative 3 squared plus minus with 3 multiply with negative 3. And then here you will get equal to negative 9. Okay, so you use calculator law, this one substitute properly. So when x is equal to 1, okay, you substitute inside y equal to 1 over 3, 1 to the power of 3 plus with 1 square minus with 3 multiplied by 1. Answer is equal to negative 5 over 3. So you get 2 points here. One is negative 3, 9. Another one is 1, negative 5 over 3. Okay, so that's it for question 1b. Now we proceed to the next question, which is 2a. Okay, for 2a, we have y is equal to x cubed plus 2x plus 1. Okay, they want us to find the point of inflection. So point of inflection is a bit different from stationary point or turning point, where this time what you guys have to do is you have to, instead of differentiate one time, right, you have to differentiate 2 times. Okay, so differentiate 2 times, and then after that you let differentiate just now 2 times, you let equal to 0, and then that is when you have to find the value of x. Find x, and then you can find y. Okay, and then we have to make sure whether that point that we got, because we have to find x and y become a coordinate, right, a point x and y. We have to make sure that this guy is an inflection point or not. So you have to differentiate the 3rd time. Okay, and then substitute the point of x inside, and then check after you substitute x inside whether it is not equal to 0 or not. Okay, if it is equal to 0, it is inflection point. If it is not equal to 0, it's not inflection point. Okay, we proceed, yeah. Okay, oh sorry. Okay, for this question, differentiate 2 times, so dy dx is equal to 3x to the power of 3 minus 1 plus with 2 plus 1, so you will get 3x to the power of 2 plus 2. Then we want to find 2 times, right? Then you differentiate again one more time, so 2 you bring in front, 2 multiplied by 3x to the power of 2 to the power minus 1 plus 2, 2 become 0 when we differentiate, so you'll get 6x here. Okay, now you get 6x. So what you guys have to do is you have to let d squared y dx squared equal to 0. Then 6x is equal to 0. Then x become 0 over 6. You bring 6 to the right side, 0 over 6 become 0 here. Okay, now this is your x, right? Okay, from this you actually can get a point which is y. Okay, so substitute when x is equal to 0, y is equal to, so you substitute 0 to the power of 3 plus 2 to the power of 2 multiplied by 0 plus 1, so y you get equal to 1. Right now you have one coordinate which is 0, 1, but then we don't know whether 0, 1 is actually inflection point or not. So what you guys have to do is you have to differentiate the 3rd time. Okay, you have 6x, right? When we differentiate become 6. Okay, and then you have to substitute x is equal to 0 that you get here. Sorry. So substitute x is equal to 0 into d3y dx cube here. So but then we don't have any variable right here, so when we substitute x is equal to 0 also, we still gonna get equal to 6 because it's a constant Okay, substitute x is equal to 0, it's still equal to 6, which is here is not equal to 0. When this guy is not equal to 0, by right the coordinate that we got, which is 0 and 1, is an inflection point. Like this. Easy. Okay, we're gonna do the same also for question B. Okay, for question B, if you see here, right, you have to expand first. So your fx is equal to, when you expand, so expand properly, yeah. Okay, so you will get, okay, to make it easier, we expand one by one. X squared plus with 2x minus x minus 2. And then here you're going to get x cubed plus 2x squared minus x squared minus 2x. So you will get here equal to x cubed plus x squared minus 2x. So this is your fx. Okay, so find dy dx first, differentiate one time. So we will get 3x squared plus with 2x minus 2. Then you differentiate the second time, you just put the prime, the apostrophe twice. Then here you bring 2 in front, you're going to get 6x to the power of, I make it easier, 2 multiplied by 3, x to the power of 2 minus 1 plus with 2. X we differentiate become 2 minus 2 differentiate become 0. So here you're going to get 6x plus with 2. Now from this, remember what we have to do? We differentiate we let f prime x equal to 0. So 6x plus 2 equal to 0. 6x negative 2, the right side become negative 2, x become 2 over 6, it is negative 1 over 3. Now from this you will get a point, substitute inside y. Okay, so when x is equal to negative 1 over 3, your fx is equal to negative 1 over 3 cube plus with negative 1 over 2 square minus 2 multiply with negative 1 over 3. Use your calculator here, you're gonna get equal to 20 over 27. So by right here you get a point, negative 1 over 3, 20 over 27. But then we don't know whether this point is an inflection point or not, right? So we have to differentiate the third time. Okay, so from this guy, 6x plus 2, we differentiate, you're gonna get 6x differentiate becomes 6, 2 we differentiate become 0. So 6, huh? So what you have to do is substitute the value of x, which is 1 over 3. So when substitute x equal to negative 1, negative wait, okay, and then here if we check here, right, we have to substitute the value of x, right, inside the after we differentiate 3 times, but then it is a constant, okay, so no need to substitute lah. So by right, this guy is not equal to 0. So the point negative 1 over 3, 20 over 27 is an inflection point. That's it for this question, question B. Okay, now we proceed to the next question where we have curve y is equal to x cubed plus 1 over 2x squared minus 4x has 2 stationary points. We have 2 turning point here, identify the x coordinate and determine their nature using differentiation. So that means we have to find their nature lah. So what does it mean by nature? If you differentiate twice and then you substitute the value of x, right, inside, if it is greater than 0, it is actually minimum point. If it is less than 0, it is maximum point. Okay, so here we have y is equal to x cubed plus 1 over 2x squared minus 4x. The first step is find dy dx. Okay, so you're gonna get dy dx 3x squared, and then 2 you bring in front, minus with 4. Here you're gonna get 3x squared plus with x, because here you cross minus with 4. This is your dy dx. The next one is you have to let equal to 0. Okay, let dy dx equal to 0. So you're gonna get 3x squared plus x minus 4 equal to 0. Then here you're gonna get 3x plus 4 and then x minus 1 equal to 0. Then you will get 3x plus 4 equal to 0, x minus 1 equal to 0. So x, you will get negative 4 over 3, another x is equal to 1. So you have 2 value of x, then you substitute inside y. So when x is equal to negative 4 over 3, okay, they have to find x coordinate only, right? Then no need to find the point, no, just x coordinate. So here from this guy we already have two coordinate of x, which is -4/3 and then also 1. Then we have to check whether it is minimum point or maximum point. So what you guys have to do is you differentiate the second time. So d square y dx square equal to, differentiate which one, 3x square plus x minus 4. Then you're gonna get 2, you bring in front, multiply by 3, x square you maintain minus 1, and then x differentiate become 1, -4 differentiate become 0. So here you're gonna get 6x plus 1. Okay, now from this you substitute sub x is equal to 1. Okay, what is the value of dy square, d square y? So 6 multiplied by 1 plus 1, you're going to get equal to 7, which is this is greater than 0. When it is greater than 0, this guy, it is a minimum point. Okay, now substitute x is equal to -4/3. So substitute inside d square y dx square. 6 multiplied by -4/3 plus 1. Substitute this, you're going to get equal to -7. Then this is actually less than 0, right? So it is a maximum point. So that's it for this question. Okay, so we proceed to the question 6. For question 4, 5, you can do on your own lah. Okay, question 6, they say identify stationary point on the curve hx and then determine the nature of each point, so which is similar as the previous question, no? Okay, so the first step is differentiate first. Okay, so we have hx is equal to 2/3 x to the power of 3 plus 1/2 x square minus 3x. So differentiate one time, so you're gonna get 3, you bring in front here. So 3 multiply 2/3 x to the power of 3 minus 1 plus with 2, you bring in front 1/2 x square minus 1 minus 3. X become, when differentiate become 3 lah. So you're gonna get here cross 2x to the power of 2 cross you're gonna get x minus with 3. Okay, here you have this guy, right? So the second step is you let h prime x is equal to 0. You find the value of x. So 2x square plus x minus 3 equal to 0. This one, it is quadratic, right? So you can use factorization. So you're going to get x minus 1. Another one is 2x plus with 3 equal to 0. So separate them. You're going to get x minus 1 equal to 0. X is equal to 1. This one, 2x plus 3 equal to 0. X is equal to -3/2. Okay, so you have 2 points here. Now, they want stationary point, right? By right, x and y you have to find. Okay, so from this, you have when x is equal to 1, your hx is equal to, substitute 2/3 multiply with 1 to the power of 3 plus with 1/2 multiply 1 square minus 3 multiply by 1. Answer is -11/6. So you have 1.1 -11/6. Okay, and then another one here is you have when x is equal to, I have to bring it a bit lower. When x is equal to -3/2. Okay, so your hx is equal to, so this one you have to substitute properly. 2/3 multiply with -3/2 cube plus 1/2 multiply with -3/2 square minus 3 multiply with -3/2. My writing. So you're gonna get 27/8. Here you will get -3/2, 27/8. the point. But then we don't know whether it is minimum point or maximum point, right? So what you guys have to do is find the second derivative of hx, which is differentiate the second time. You're gonna get equal to 2, you bring in front, so you will get 4x, then plus x, as differentiate become 1, negative 3 differentiate become negative 0 lah. Okay, so this is your hx. So what you guys have to do is substitute hx inside. So substitute when x is equal to 1, so your h prime x is equal to 4 multiplied with 1 plus 1, it is equal to 5, correct? So by right, 5 is greater than 0, then it is minimum point. Do the same also for the next one, for when x is equal to negative 3 over 2. So you substitute inside 4x plus 1, 4 multiplied with negative 3 over 2 plus with 1, you're gonna get equal to negative 5. And then here it is less than 0. By right, this is a maximum point. That's it for question 6. Okay, now we proceed to the question 7. Question 7, for the curve, you have to find stationary point and point of inflection. So this is the same. Okay, so this one, the first step is we have this equation y, x cubed minus 12x. So to find stationary point, differentiate, you're going to get 3x squared minus with 12, and then you let dy dx equal to 0, then 3x squared minus 12 equal to 0. From here you factorize it, you will get here 3x squared equal to 12, then x squared, 12 divided by 3, x squared become 4. Then to find x, plus minus square root 4 become plus minus 2 loh. So by right, your x is equal to negative 2, another one is 2. And then here you get 2 value of x, then you can find y. So for x is equal to negative 2, your y is equal to 2 to the power of negative 2 to the power of 3 minus 12 to the power of negative 2. The answer is equal to negative 16. Then when x is equal to 2, your y is equal to 2 cubed minus 12 multiplied by 2 equal to 16. Okay, so we already got a point here, which is negative 2, negative 16. Another one is 2 and 16. So now we have to identify whether this is minimum or maximum lah. Okay, no, they didn't mention, right? So they just want to find stationary point and the point of inflection. We get already the stationary point, these two just now. Okay, stationary point. Now we have to find point of inflection, where we have to differentiate the second time here. So d square y dx square equal to, so we have 3x squared minus 12. So when we differentiate, you bring 2 in front. 2 multiplied by 3 becomes 6. X to the power of 2 minus 1 becomes 6x. Okay, this one 6, you bring in front, 2 multiplied by 3, x to the power of 2 minus 1, negative 12, we differentiate becomes 0, so you will get 6x. Okay, then you let d square y dx square equal to 0, 6x equal to 0, then x is equal to 0. Now this is the point that you get. So when x is equal to 0, what is the value of y that you have? So the value of y become y, you use 3x squared, so 3 multiplied by x to the power of y is equal to x squared minus 12x, right? So x cubed, 0 cubed minus 12 to the power minus 12 multiplied by 0, y is equal to 0. So here we have to check whether this is inflection point or not, right? Okay, so you have a point 0, 0. We don't know whether it is inflection point or not, so you differentiate the third time. Okay, so 6x you differentiate becomes 6, so this 6 is not equal to 0, right? So it's a constant, it's not equal to 0. By right, what you have to do is you have to say lah, the point 0, 0 is not inflection, it is an inflection point. Like that. Okay, so that's it for question 7. Okay, now we do question 9. Okay, for question 9 is a bit long, this question, yeah. Okay, sorry, for question 9 we have y is equal to 2x cubed plus 3x squared minus 12x plus 7. Okay, they said calculate the x-intercept, y-intercept and turning point and its nature and the point of inflection. They ask everything that they can ask. So they ask x-intercept and y-intercept. So find x-intercept and y-intercept first. X-intercept, you have to let y equal to 0. So 2x cubed plus 3x squared minus 12 x plus 7 equal to 0, and then you have to find the roots. Okay, so by right here you will get sorry, 2x plus 7, x minus 1 and x minus 1. So from this, when you factorize by right, you will get x is equal to negative 7 over 2, then x is equal to 1, and then another one is x is equal to 1. So by right, it is x is equal to 1 only lah. Okay, so you have 2, then your x-intercept is this 2 value right now. You have to find your y-intercept. How to find y-intercept? Let x is equal to 0, then here you substitute y2 equal to 2 multiplied by 0 to the power of 3 plus 3 multiplied by 0 square minus 12 to the power of 0 plus 7. So here you're gonna get y is equal to 7. This is your y-intercept. So you get this already, right? So by right now you have to find the turning point and its nature. So to find turning point, differentiate first. So you have y, differentiate dy dx, you will get, okay, I've copied first lah, the value of y. So when we want to find dy dx, you will get 3 you bring in front becomes 6x squared, 2 you bring in front becomes 6x, then negative 12x become negative 12, 7 becomes 0. So then you let dy dx equal to 0. Okay, then 6x squared plus 6x minus 12 equal to 0. Then here you find the value of x. Okay, all of them are factor of 6, so you divide by 6, you're going to get 6x squared plus x minus 2 equal to 0. Factorize this, x plus 2, x minus 1 becomes 0. So one value, x equal to negative 2, another one is x is equal to 1. Okay, from this, because we want the point, right? So you substitute when x is equal to negative 2 and when x is equal to 1 inside y. Y is equal to 2 multiply with negative 2 to the power of 3 plus with 3 multiply with negative 2 to the power of 2 minus with 12 multiply with negative 2 plus with 7. Then you will get 27. So from here you have one coordinate, negative 2 and 27. Now substitute when x is equal to 1. You're going to get y is equal to 2 multiplied by 1 cube plus with 3, 1 to the power of 2 minus with 12 multiplied with 1 plus 7. Then here you're going to get equal to 0. Then you will get 1, 0. Okay, so you have two coordinate, which is the turning point and Now we have to find the nature. Okay, so to find the nature, right, I think I have to bring this guy a bit below. Okay, to find the nature, we have to differentiate the second time. So do we have the differentiation of second time? No, we don't have. So we have to differentiate this guy for the second time. So d square y ds square equal to 12x plus with 6. Okay, so you got this. Then what you have to do is substitute x inside. So we have d square y ds square equal to 12 x plus 6. So substitute, substitute when x is equal to negative 2 plus with 6, right? Okay, here you will get the total equal to 18. No, negative 18. So it is less than 0, so it is maximum point. Now you substitute also inside this guy. So d square y ds square, you're going to get 12 multiplied with 1 plus with 6, total is 18, which is greater than 0. It is minimum point. Okay, like this. Now settle for the nature. Then they want point of inflection. So for point of inflection, bring this up a bit. Point of inflection, you have to differentiate the third time. Okay, so d cube y dx cube equal to, differentiate third time, become 12x plus 6, differentiate become 12. So this is not equal to, we want to find the to find the inflection point. To find the inflection point, you have to let d square y ds square equal to 0. So you have 12x plus 6 equal to 0. Then you have to find x here. You're going to get negative 6. X is equal to negative 6 over 12, which is negative 1 over 2. Okay, so the next one here, since you get x is equal to negative 1 over 2, then you have to find y. So y, you substitute inside, substitute x is equal to negative 1 over 2. So we get negative 1 over 2 cube plus with 3 multiply with negative 1 over 2 square minus 12 multiply with negative 1 over 2 plus with 7. Total you're going to get equal to 27 over 2. Okay, now we have a point, negative 1 over 2, 27 over 2. We don't know whether it is inflection point or not, right? So we differentiate the third time. Okay, equal to 12, right? So since d square y dx cube is equal to 12 when we differentiate, which is this is not equal to 0, then negative 1 over 2, 27 over 2 is an inflection point. Okay, that's it for question 9. Okay, so you guys can attempt question 5 for the subtopic tutorial. Okay, and then you submit your answer through the form. Okay, your submission will be counted as attendance. No need to worry that you guys submit late, but once you submit, I'll just count your submission as attendance. Just make sure that you submit. Okay, so make sure you submit by Monday 5 or 5 p.m. lah. Okay, thank you.